Hello dear aspirants, this is Dr. Sourav Sir's class. We are solving some questions about statistics. So this question is telling us that consider an M by M by 1 MM1 queuing model with arriving rate lambda equals to 15 per hour and service rate mu equals to 45 per hour. Let nt denote the number of customers in the system at time t, which is lying between 0 to infinity, so positive time, and also let t1 and t2 be the amounts of time a customer spends in the queue and in the system respectively. Then which of the following statements are true? As our option 1 is telling us that limit t tends to infinity, p of n of t is equals to 1, then it's equals to 2 by 9. And our option 2 is telling us that probability when our t1 is greater than 0, that is equals to 1 by 3. Option 3 is expectation of t1 is equals to 1 by 90, and option 4 is telling us that expectation of t2 is equals to 1 by 35. So what can be done in this question? So to analyze the m by m by 1 queuing system, let's calculate the required probabilities and expectations step by step. So my arrival rate is what? That is my lambda equals to 15 per hour. And service rate is what? Mu equals to 45 per hour. Sorry, 45 customers per hour. Yeah. So traffic intensity is what? So rho is equals to my lambda by mu, which is 15 by 45, which is equals to, sorry, 1 by 3. And nt is the number of customers in the system at t. T1 is the time spent in the queue and T2 is time spent in the system. So firstly we have to think about the long term probability of nt equals to 1. Okay. So in an MM1 queue, the steady state probability P of n equals to n is given by, that is equals to 1 minus rho into rho to the power n, where our n is 0, 1, 2, dot dot dot. Now for n equals to 1, what will happen? Probability when our n is equals to 1 is equals to 1 minus rho into rho. That will be 1 minus 1 by 3 into my rho is 1 by 3. So it is 2 by 9. So our statement 1 is true. Yeah. So now we have to think about our option 2. So now the probability when our t1 is greater than 0 is equals to 1 by 3 is the given in the option 2. So the time spent in the queue t1 is positive only when the server is busy. So which happens with the probability p. So probability rho, so what will happen here? So p equal, so probability when our t1 is greater than 0, then it is equals to rho, and that is equals to 1 by 3. Yeah, so our statement 2 is telling, okay, our statement 2 is also true. Yeah, so now we have to think about our option 3 and 4. So we have to calculate the expectations now. So what will happen here? Yeah, so we have to now calculate the expected value of t1. So the expected time in the queue t1 is given by expectation of t1, which is equals to rho by mu into 1 minus rho. So we are going to substitute the values where our rho is 1 by 3 and mu is equals to 45. So what we will get? Our expectation of t1 will be now 1 by 3 into that will be 45 into 2 by 3. So 3 and that will be cancelled out. So we will get 15 here. So we will now get that is equals to 1 by 90. So our statement 3 is also true. Yeah, our statement 3 is also true. So now we have to think about our option 4. So that is telling us to find out the expected value of T2. Okay. So the expected time in the system T2 is given by expectation of T2 that is equals to 1 by mu minus lambda. So that will be what? Our lambda is equals to 15, we all know that, and our mu is equals to 45. So 1 minus mu minus lambda will be 1 minus 1 by 45 minus 15. So that will be 30. So I think they gave us 1 by 35. So that will be wrong because our answer is 1 by 30. So this option will be ruled out. So the correct options of this question are my option A, B and C. Hope you understood, guys. Thank you.